Welcome to tutorial sheet 4, and in this video we're simply going to be doing two questions on every question, like two babies on each question, and I'll be leaving the rest for you to attempt to see if you've grasped the concept. So in question 1 I'll solve the first one and then the last one. So we are having 2x cubed. So this is question 1. We have 2x cubed, then we have 6x, so we have a 6x squared minus x minus 3. This is being divided by 2x cubed, 2x cubed then minus 1. So they're already specified for us to use long division, so that's because the divisor is simply also a polynomial. So we're simply going to put the divisor in expression in a way that shows the descending powers of x. So this is what you have. We need to show every place value of x. Then the polynomial is just okay. There's no need of putting a 0 anywhere. It's perfect. We divide by the first term, which is 2x cubed. This is going to be a 1. And when we multiply everything, this is going to be 0x squared, then plus 0x. And then this is going to be a negative 1. When we subtract, this is simply going to give us a 6x squared minus x, then this is going to be minus 2. So according to this, the remainder that we're getting is simply 6x squared minus x minus 2. And the quotient q of x is simply a 1, the guy here on top. The reason why we cannot continue is because the remainder is at a lesser degree. This expression that we're getting at this stage is at a lesser degree as compared to the divisor. So our expression just ends up to here. That's what you do on question 1a, or Roman numeral 1. Then the last one, this is also very straightforward. The polynomial is x to the power 5 plus 7. The divisor is x to the power 3 minus 1. So we're simply going to have, so this is number 4, question 1. So this is going to be, this is our divisor, minus 1, and our polynomial is simply going to be like this. We need to show all the place values of x and 2. We have our constant this side, which is 7. We divide by x to the power 3, that's going to be x to the power 2. We multiply everything here by x to the power 2, that will be x to the power 5, 0x to the power 4, 0x to the power 3 minus x to the power 2. And here we subtract, everything goes away except for x squared plus 0x plus 7. We cannot do anything here because the divisor is at a higher degree than the remainder that we're getting here. So right here, the remainder is simply x squared plus 7, and the quotient is simply x squared. So this is basically what we get on number 1. So that's what you do on question number 1. Here we have no choice than to use long division because all the divisors are not linear factors. So if they are linear, you are at liberty to either use synthetic or long division, but here it's just long division strictly. So that's your number 1. Then your question 2, they are saying write each of the following in the form of this, meaning each and every divisor here is a factor of whatsoever you are given. So here I'll just solve 2 as well. I'll solve the first one and the third one. So this is just going to be, I'll use synthetic in the first method to solve the first one, So I'll solve this guy here. That's x plus 1. X plus 1 is equal to 0. That's x is equal to negative 1. So now that you have a negative 1, you can just say we have, this is question 2. We're doing the first one and the third one. So that's 1, 6x, then plus 8x, then plus a 3. We are dividing it by x minus 1. That's what x plus 1, That's a plus 1, so that when you solve this, it gives you x is equal to negative 1. So because it's a linear, we can use synthetic, put the coefficients. So we are putting the coefficients of the polynomial. In front here, there's a 1, that's a 1 here. The 6, the 8, and the 3. Bring down this 1, then multiply. This is going to give you a 5. That's a 5. Is it? We are on question number. This is 1683. Let me see if I've copied the right thing. Then we are using this, which is a -1. So this is going to be a 5. That's a -5. I mean, this will be -5. 8 minus 5, or we're adding, that's going to be a 3. That's a 3. That's going to be a 0. The remainder is a 0, meaning x plus 1 multiplying this x squared plus 5x plus 3 is the same as the what? Is the same as the polynomial. Now we know what they wanted. So here we're just going to say where a is equal to 1, our b is simply 5, and our c is what? 3. Regardless of this is a plus or it being a plus or minus, we're just saying we have to get a quadratic this side. No wonder they were showing us this form. Yeah, this format here, this. So that's what they want at the end. So we tell them what the a, the b, and the c are. Yeah, so that's what you do. We could have used long division as well, but the answer will still be the same. So I'll use long division for my third one here. That's simply x to the power 3. So we're still on question 2, the third one. We're dividing with x minus 5. Okay, so x minus 5 is what we're using. Then we're having -8, 13, 10. -8, 13 with a 10. That's x to the power 3. That's x squared. That's plus x. Then that's plus 10. We divide there. That's going to be x squared minus 5x squared. We're subtracting, so this is going to be give us a -3x squared. Then bring down the 13. This is going to give us -3x, and this is going to give us -3x squared then plus 15x. Is this a 13? Is this a 13? Yes, that's a positive 13. Okay, let's see what we are getting. This is a minus. So this is going to give us what? This is going to give us 13 minus 15. That's going to give us a -2x. Then we're bringing down the 10. The 10 has to come down like that. That's -2. That's going to be -2x. Then that's a plus 10. So this here is just going to give us a 0. Meaning this here is our ax squared plus bx plus c. That's our quotient. Still, you notice that the outcome is still the same. Yeah, so this is how we do every single question on number 2. You can either use long division or synthetic because these are all linears, right? Meaning the degree of x is simply 1. Yeah, so that's what you have. It's similar to number 3. Number 3 is just the same. They're saying show that the left hand side is equal to the right hand side. So here you can do it in 2 ways. We can start with the right hand side. The easiest way to do here is to start with the right hand side. Yeah, so we can just start with question 3. I'll just take the right hand side directly and solve it. That's x plus 2 and x squared minus 5. You notice that when you expand this, that's going to be okay, so this is x, that's 5. That's going to be x squared then minus 10. You notice this 2x squared minus 5x then minus 10. You notice this is exactly the same thing as the left hand side, hence shown. This is what they basically want. This is how you conclude something that says show. Yeah, because they already know that the left and the right are the same. We just have to show that one side is equal to the other side. Yeah, so that's what you do on number 3. Then now number 4, I'll put a title to number 4. So in question number 4, so question 4 is under the remainder theorem. So just one point to note, whenever the remainder is 0, it simply means that that particular expression is a factor. So the expression is a factor of that polynomial. Is a factor. That's basically what we mean. Whenever the remainder is 0, right? Then when the remainder is a non-zero digit, so whenever it's a non-zero, it means it's not a factor. For example, 2 can divide 15, right? But it leaves a remainder of 1. So 2 is not a factor of 15, right? If you have 2 in there, Chimabas equation, this is going to be 7, 14, and what, 1, right? So the remainder is 1. But if you use 3 in 15, this is simply going to give you what? A 0. So 3 is a factor of what? Of 15. In short, 15 can be written as 2 times 7 plus 1. 2 times 7, then plus what? 1. This is the polynomial is equal to the divisor times the quotient, then plus the what? The remainder. But if the remainder is 0, meaning you're just going to have the polynomial is the same as the divisor and the quotient, because the r of x there is 0. So that's what we mean by the remainder theorem. So to answer your question number 4, so question 4, we're just saying use this. So they've given us linear factors throughout. So they're saying find the remainder when we divide by that. So we'll simply say the first one. So that's question 4. That's x to the power 3. 4 negative 3, 2. 4 negative 4 negative 3, then plus a 2. We're dividing this by x minus 5. So I'll show you the first method that you can use. Method 1, the remainder theorem just suggests that if the divisor that you're using is a linear, you can just solve it. This is that. Then equate this to 5. And also replace this 5 in the expression. So we're going to put 5 wherever there is a x. Then this is 3, put a 5 there, then plus a 2. This is just going to be 125. Then plus 4, this is a 25. 25 minus 15 plus a 2. This will be 125. Is this true? They're saying find the remainder, right? This is going to be what, 100. And it's going to be minus what? Minus 13. So this is going to be 225 minus 13. That's going to give us a 2, 1, and a 2. So the answer we're getting is this. So according to the expression, when they say what? They say find the remainder when this, okay, so this is a positive 5. Sorry, here I've made a mistake. It's supposed to be positive so that when you solve it, it's negative, right? So we needed to replace negative. Yeah, so it was supposed to be a negative value. This is going to be, if we do the right thing, this is 3 and negative 5, then plus a 2. This will be negative 125, then plus 100, plus a 15, then plus a 2. This here would have given us negative 25, then plus this is what? This is a 17. Then we're simply saying this is going to give us what? A negative. That's the 3 should give us negative 8 if I'm not mistaken. We can just clarify it using synthetic, negative 5. Then we put the coefficients, which is 1, 4, negative 3, and 2. If you put the 1 there, that's negative 5. That's going to give us a negative 1. That's going to be a 5. This 5 minus 3, that's simply a 2. This and this is negative 10. Sorry, this is a negative 10. Then when you add this, you are getting a negative 8. So let's check. So the answer here is correct. It's supposed to be negative 10. So that's the remainder. So the remainder here for the first one, they just want the remainder. It's negative 8. You could have done this method, synthetic, or you could have just replaced the figure like we've done here. This is the correct thing. I made a mistake here, so ignore this part. So you could have done this, or you could have used long division. Yeah, so this is method 1. Right here, I've given you method 2, synthetic. Or you'd have done long division. The outcome is the same. So that's what you do for every question or number 4. Yeah, so just do one here because it's very straightforward. Then number 5, they're saying show that when this polynomial is divided by x minus 1, the remainder is what? Is 5. It's the same thing as number 4. We're just going to solve this. This gives you 1, right? Put the 1 there. That's going to be 3, 1. The power 3 minus 2. Put a 1 there squared plus a 4. This is a 3 minus 2 plus 4. This is just a 1 plus 4. This is what? 5 as required. So you put as required because they knew the answer. They just wanted us to show that the answer is what? Is 5. Now number 6, they're saying This expression here is a polynomial. They're saying find the remainder when it's divided by x minus 3. It's the same thing. We're simply going to use synthetic. It's easier and faster. We solve this. This gives us x is equal to 3. We put our 3 here. So that's your number 6. Then you put your coefficients. That's a 3, negative 14. Making sure that the powers of x are nicely descending. That's a minus 14. We bring down the 3. That's going to give us a 9. This will give us a 5. That's going to be, this is going to be 3, right? That's a 9. Then you're saying negative 14 plus 9. That should give us negative 5, right? So we're saying 14 minus 9. Yes. Okay. And then when you multiply 3 by this, we are getting a negative 15. When you add this, that's going to be 2, remainder 1. Then that's 4, 5, that's going to be 6. When you multiply this, you're going to get, that's a 6. And you're getting that. 3 times, that's 18. Sorry, this is supposed to be, we're saying 62 multiplied by 3. That's 186. Negative 186. So when you add up this, gives you negative 200. So the remainder here is simply negative 200. That answers your first question on number 6. So whichever method you're going to use, the answer has to be negative 200. That's what you get. Yeah, so the answer here is that the remainder is negative 200. Then number 2, they're saying given that x plus 2 is a factor, factorize it completely. So if it's a factor, it simply means the remainder is 0. So this is question 6, Roman numeral 2. That's x to the power 3. That's going to be, there's a 3x, there's a 3 in front. This is 14x squared minus 47x, then a minus 14. We're dividing it by x plus 2. So I'll solve this. That's going to be x is equal to negative 2. Synthetic again, because it's easy and fast, we have this. We have a negative 47, then we have a negative 14. Bring down the 3. That's going to be negative 6. That will be a 20. That will be a 40. That will be a negative 7. That will be a 14. We get a 0. So meaning that x plus 2 and the quotient, which is this part here, the quotient has to be 1 degree less as compared to the polynomial that you had. So this will be x squared and x. So this is 3x squared minus 20x, then minus 7. This is what we are having as our polynomial. We can solve this part. The product there is simply negative 21. The sum is negative 20. So our factors will simply be negative 21 and 1. This will be x plus 2. This will be 3x squared minus 21x, then plus x minus 7. Then this will be x plus 2. And this will be 3x, x minus 7, plus 1, x minus 7. Then this will be x plus 2, 3x plus 1, and we're having x minus 7. So when they say factorize completely, this is what they mean. You just leave it at this point where you have these 3 factors. This, when multiplied or expanded, it will give you back the polynomial. So this is what we are having to be the factorized, the completely factorized version of our polynomial. Now, when they want us to sketch, or when they ask us to graph the function, we're simply going to solve each piece and equate it to 0. So we're going to get what we call the roots. So f of x is equal to 0. We get the roots, or rather, we get the x-intercepts. It's the same thing. So when you solve this, you get x is equal to negative 2, x is equal to negative 1 over 3, x is equal to 7. The y-intercept is simply the constant in the question, which was y is equal to negative 14. When you go back to the question, the constant there is negative 14. It will help us to sketch, because when we are sketching, we are simply going to have negative 2 and negative 1 over 3, and we have a 7, and we have negative 14 that we need to touch. So our graph will just go like that, come like that, and also be like that. So this is going to be your sketch. This is the sketch of your function. If the constant in the question, or the y-intercept, was positive somewhere there, the graph would have been the other way around, like this. This is how the graph would have been. Yeah, so that's how we do questions that involve us to sketch polynomials. Yeah, so that's what we are simply going to do also on number 7. It's the same thing. So let me just give you a guide. So number 7, the first thing first, this is similar to number 2. Number 2, they want us to divide this into that to give them the A, B, C, right? What we did on question 2 is what you are going to do here as well. So we're simply going to shorten the whole process and just use synthetic. So I'll solve this guy. It gives me half. That's half. Then I'll put it here. That's a half. Then I'll get the coefficients of the polynomial. That's 2. That's a 3. Negative 8. That's a 3. I'll bring my 2 down. That's 1. That's a 4. Half it. That's going to be a 2. Negative 6. Half it. That's a negative 3. Then you get a what? It's 0. Simply meaning that your answer to this question here to get this is simply your 2 what? Your 2x squared plus 4x then minus 6. That's your answer here. Yeah, because we've gotten the quotient, right? That's what you're having. And it will even help us now when they say factorize completely. We'll just use the same. We already have 2x minus 1. We just don't have the simplified version of our quadratic here. So the product there is negative 12. The sum is 4. So the factors that we're going to use are simply going to be negative. We're going to use a 6 and then negative 2. Yeah, so when we do the math there, we're going to have 2x squared minus 2x then plus 6x then minus 6. This will be 2x then x minus 1. This will be plus 6 then x minus 1. So this will just be 2x minus 1, and the other two factors will be x minus 1, and the other one will be 2x plus 6. So these are simply the other two factors you're going to get. And then question number 3, they're asking us to write down the roots, meaning when we equate this whole expression to 0, what are the values of x? What are the x-intercepts? When you equate this, you simply get x is equal to half. You simply get x is equal to 1. You get x is equal to negative 3. Then the last one, they want you to sketch. So sketching here shouldn't be a problem. You can pause the video first and attempt it. I've given you the 2 answers, the 3 answers I mean. You have half, 1, and negative 3. Half, you have 1, and x is equal to negative 3. Those are the x-intercept. The y-intercept is simply, when you look at your question, it's a positive 3. So meaning, if you have to touch these 3 points, this is what you're having. There's half, then there's a 1, then there is what? There's a 3 here, right? So how else can we touch them? We have to move like this, something like this, then it goes like that. So this is how the graph of the function on question 7 would look like by the time you are done. Hope this is okay, because we're just repeating principles now. So now if we even proceed to number 8, 8 is the same thing like the number 6. They're saying show that this is a factor. How do we show something is a factor? The remainder has to be 0, right? You can just solve this. X is equal to 1. Plug in the 1 there. Then you have 1, this is 6. You have a 1 there. You have 5. And a 1 there minus 12. This whole thing becomes what? 0. So you've shown, or you can use synthetic. The answer will still be the same. So we're going to say the conclusion is that x, so you say the remainder Rx is equal to 0. You say hence x minus 1 is a factor of, you write the polynomial, it's 6x squared then plus 5x then minus 12. So because the remainder is what? Is 0. It shows that you understand what you're doing. Then number 9, they're saying use the factor theorem to show that this is a factor. It's the same thing as number 8. You just solve this guy. This is x is equal to what? Half. When you put the half here, everything becomes what? A 0. So you can attempt number 9. The answer must be a 0. They're the same. Then look at number 10 now. 10, they're saying for each of the following functions, factorize the right hand side fully and sketch the graph of f of x. So if we are interested in getting the graph of a polynomial like this one here, I'll solve the first one. So that's question 10. So question 10, I'll solve the first one, which is 2, 5, negative 4, negative 3, 2, 5, negative 4, negative 3, that's x to the power 3, plus x squared, minus x, this is what you're having. They want us to sketch this, 2x3 plus 5x squared minus this is what we are getting. So if we were to sketch this expression, the first thing we need to do, okay, that's correct. So if we were to sketch this, the first thing that we do is to look at the constant. We have to factorize it first. So the constant is 3. What numbers can divide 3 without leaving a remainder? There's plus or minus 1 and there's a 3. So we're going to use trial and error method. When x is equal to 1, if x is equal to 1, can this become a 0? We try, plug it in. We're looking for a factor, and you have to just try. When it fails, we'll try another number. Amongst these numbers here, we have 2 plus 5 minus this. So this happens to give us what is 0, right? So this means that x minus 1 is a fact. How did I get the x minus 1? I just took the 1 back because this is the same. X minus 1 is equal to what? 0. So this is a fact. Yeah, that's how we get this first thing. Once you get the first thing, which is x minus 1, it's easy to get the rest, because when x is equal to 1, you can just plug it in there. There is a 2, 5, negative 4. There's a 2, 5, negative 4, negative 3. Bring down the 2 there. This is going to be 2. That's 7. 7. That's going to be a 3. Then this is going to be a 3, gives you a 0. Meaning f of x is equal to the first factor and the quotient that we've gotten, the 2x squared plus 7x and plus 3. We try to solve this as well. So this is going to be products among factors. The factors we're simply going to use will be 6x and x and 1. Yeah, so we have this. So from here, we'll just have x minus 1. Then this is going to be 2x, x plus 3. This will be plus 1 and x plus 3. Then this will be x minus 1, and then you have 2x plus 1, and you have x plus 3. So we have factorized it completely. We can now solve this. This gives you 1. This gives you negative half. This gives you negative 3. So now if we were to sketch this, we have a negative half, then we have a 1, then we have a 3. The constant in the question was negative 3, so we need to touch negative 3 there. Negative 3, I mean. Yeah, so meaning we have to move. We have to move in such a way that touches these 3 points. Our graph will just be like this. Yeah, passes here at 3. This 3 must be there. So this is how the graph is supposed to come out. That's what you need. This is what you do for all questions on number 10. Even number 11, except on number 11, you don't even finish it off. They just want you to leave it at this point. Like here, we have factorized it completely. No sketching, no nothing. Just leaving it at this stage. That's what you do on number what? On number 11. So I want to do number 11 because it's the same thing. Then now, number 12 is testing us whether we know the remainder theorem. So they are simply saying these two guys are factors. There is x plus 1. These are factors of this polynomial, meaning that the remainders are 0, or rather if we plug in the actual values of these factors, which is negative 1 and 2, the answers must be zeros, right? That's what we're basically saying. So if we do that, we're simply saying solve this, gives you negative 1. Solve this, it gives you a 2. If you put negative 1 in the whole expression, so it's going to be c negative 1 to the power 3 plus d negative 1 to the power 2 minus 9 and negative 1, then minus 10 is equal to 0. This will end up being negative c, then plus d, then plus 9 minus 10 is equal to 0. Then the down part, I mean the other part, if you replace with 2, that's going to be 8c. So you have 8c, then plus, that's going to be a 4. That's a 4d, then minus 18, then minus 10. This also gives us a 0 because it's also a factor, right? Then if we have created these two equations, we can solve them simultaneously because they have two variables that we're interested in. So the first one can just be rewritten. 9 minus 10 is negative 1. Negative 1 crosses on the other side. becomes positive 1. Here we're having 8c, then plus 4d. This is going to be 28 if it crosses on the other side. So I'll multiply the first equation by 4 just to make it uniform with the other one. This will be negative 4c, then plus 4d is equal to 4. The down part 8c plus 4d is equal to 28. Then we sum up this part. We subtract, this is going to be negative 12c is equal to negative 24. We divide by negative 12. So meaning c is equal to 2. Once you get your c to be equal to 2, you can replace it in one of the equations. I'll choose the first one. Negative, where they say I put 2. I'm looking for d, meaning d is equal to 1 plus 2. So d is equal to 3. So this is what you do on number 12. It's similar to what you're also going to do on number 13. The only difference is that on number 13, we just have one factor. So if this is a factor, meaning that x is equal to negative 2 over 3, when you solve this, right, you get this. When you put this expression here, everything must be equal to 0. That's what we're saying. So that's going to be question number 13. Question 13, that's 3b negative 3. So there's 3b negative 3 minus 2. That's bx3. Bx squared, then that's going to be this. And they're saying 3x plus 2 is a factor. So x is equal to negative 2 over 3. Then when you put the expression here, this, when you put it there, we're saying 3 negative 2 over 3 to the power 3 plus b negative 2 over 3 to the power 2 minus 3 negative 2 over 3 is equal to 0. This is going to give us 3 negative 8 over 27. This is b, that's going to be 4 over 9. This is going to be plus 2 minus 2. This cancels. Because 3 and 3 cancels, they'll give us negative 1, negative 2, that's positive. Then 2 minus 2, that's a 0. Here, 3 there is 9, so you have negative 8 over 9, then plus 4b over 9 is equal to 0. We can multiply throughout by a 9. This is going to be negative 8, then plus 4. This is going to be 0, meaning 4b is just going to be equal to that, meaning b is equal to a 2. Now, once you get your 2 to be your b, meaning here you know to say this is supposed to be what, a 2, right? Now they're saying factorize this guy completely. So use what? Synthetic, the same thing that we're from doing. So I'll leave this to you. You can, if you have doubts, you can just show me your working, then I'll be able to guide. But this is similar to the other principles. So that brings us to the end of polynomials. The next section is simply going to be on inequalities, rational function, and also radical functions. Okay, so question number 14 is under rational functions. So under rational functions, we have 3 cases, but here they're just going to be dealing with 2 cases. So I'll just solve these questions. There's a separate video that has the full lesson. You can just check it out on the channel. So we'll start with the first one. This is on rational functions, number 14. So the first one, here we'll do everything. Okay, so question 14 is under rational functions. On the first one, we're simply going to look at a case where the denominator has x and the numerator doesn't have x. This is called bottom dense. Sometimes the numerator can have x, but it's at a lower degree as compared to the denominator. Let's say you have x, then here you have 2x squared. So something like this. The way we handle this is how we are going to handle such a case as well, because they are all in the same category. That's what we have. Now, the first thing you have to do here is to get what you call your vertical asymptote. Or we'll start first of all with getting the domain. So the domain is all real numbers, but the down part should not be 0. So we solve the down part. The down part can only become a 0 if x is equal to 2. So we eliminate 2 from the real number line. Everything else is allowed, but not 2. Then for this case, the range is fixed. The range is always going to be all real numbers, but not 0. So y should be allowed for all numbers, but not 0. That's simply the range. It's fixed. It's always going to be like this, provided it's bottom dense. Yeah, meaning the guy down has x, or it's at a higher degree as compared to the numerator. Then we have to get what we call the vertical asymptote. So the vertical asymptote is simply the number that the domain is not allowing. So when you solve the down part, you got what? X is equal to 2. That's our vertical asymptote. The horizontal asymptote is the number that the range is not allowing. So the horizontal asymptote, that's going to be y is equal to 0. Then from here, we can now proceed and get the domain. I mean the x-intercept, sorry. The domain is already here in the range. We have the vertical asymptote. And we also have the horizontal asymptote. We have them here. So the x-intercept, the x-intercept is when y is 0 or when f of x is equal to 0. When you put 0 this side, you notice that it's not going to exist, because if you try to solve this, it won't make sense. This is going to be 0 is equal to -4, which is not true. So the x-intercept does not exist. So we write DNE. That's what we have. And the y-intercept, if you're looking for the y-intercept, we put x to be 0. So in the whole expression, wherever there's x, we put a 0. So that's just going to be a 2. That's what you are getting. So this is the only information that you need for you to be able to sketch. And if we come here and make the sketch, we're just saying the vertical asymptote is 2, implying that we should never touch 2. So 2 can never be crossed. That's what we basically mean. And also y is equal to 0. So y is equal to 0 happens to be the x-axis. So this is the guy that I'll show here in blue. That's your horizontal asymptote. So we have our horizontal asymptote and we have the vertical asymptote. Then the y-intercept is simply 2. That's what we are having. That's a 2. We have a 2 there. So meaning the graph will go like this. We need to touch this line and also go like that, because we can never cross the vertical asymptote and the horizontal asymptote. Then the twin will be in the other section. This is basically what you get. So that's what you have as your sketch or your graph for the first one. Then for the second one, this is when they're of the same degree. The denominator and the numerator are of the same degree. Yeah, so whenever you are sketching and there's an intercept, in this case we had a y-intercept, we need to show a twin to that graph that you've sketched. So the real number line or the axis, the x or y plane is demarcated into 4 sections. We have this guy and this guy and this guy here and the last section there. So if your first graph is here because of the intercept, and we cannot cross, no wonder we are coming like this and going up, because we can never touch this line, no touch this line here. So we just have to go as close as possible to it. The twin is going to be the opposite. So here the twin is there, the opposite quadrant sort of. So it's going to be here. This is why we are drawing this other guy here. And if we were to sketch the second question on 14.2. So the same way that we've done number 1 is the same way that you do number 4. So you can try this. And the same way that we're going to do number 2 is the same way that you do number 3 as well. So let me solve number 2. So 14.2. So 14.2, we are having f of x. F of x is equal to 6 minus 2x. Then down, we just have 1 minus x. So you can go straight ahead and get the domain here. So what's the domain here? You can try to pause it, try to get it first. You solve the down part. So let's see if you've gotten the same answer. So this is just going to be 1. All numbers, but x should not be equal to 1. Then the range, we're just saying all numbers. For this case, we get the coefficient of x in the numerator divided by the coefficient of x in the denominator. That's how we get the range of this guy. Y should not be equal to -2 over -1. So whenever the x has the same power in the denominator and the numerator, this is what we always do to get the range. So here we're just going to say all numbers but not 2. You notice that the case here is different from the previous question. The previous question, there was no x in the numerator. So because there was no x in the numerator, we went straight forward and said the range is just this here. all numbers but not 0. Because if you were to get the inverse of the function and try to get the domain of the inverse, it will be exactly this. We know to say the domain of the inverse is equal to the range of the original function. So the easier way, no wonder I said this thing is fixed, provided there is no x in the what? On the numerator. But here we have x, and when you have the same degree, this is not bottom dense, they are of the same degree. We are always going to be getting the coefficient of x in the numerator divided by the coefficient of x in the denominator. And this is important that you show the domain and the range, because they will help you to get the vertical asymptote. So the vertical asymptote is the number that was not allowed by the domain. So it's x is equal to 1. The horizontal asymptote is the number that's not allowed by the range, which is just y is equal to 2. Then from here you can get the x-intercept and the y-intercept. If you attempt that, so the y and the x-intercept, just replace where there's f of x, put a 0. F of x is equal to 0, meaning we're getting the x-intercept. This is going to be 0 is equal to 6 minus 2x. Then you have 1 minus x. When you cross multiply this, it will be negative 2x is equal to negative 6. Divide by negative 2, meaning x is equal to a 3. Then when you put, wherever there's x, when you put a 0, this is going to be f of x is equal to, you have 6 minus 0 over 1 minus 0, meaning y is just equal to 6. So we have the x-intercept and we have the y-intercept. Then now we come here, we try to sketch this. The asymptotes, I'll show them using blue. So the asymptote, remember there was a 2, so we should never touch 2, that's what you have. And also we have 1, so we should never touch 1, that's what you have. So you have something like this. Then the x and the y-intercept, the x-intercept is 3, so this is a 1 that you should never touch, there's a 3 there. And also the y-intercept was simply 6, so that's the 6, we should touch 6. 6 is above 2 somewhere there, so meaning we have something there, it goes like that. And we also have the twin somewhere here, and it goes like that. So this will simply be your sketch. This will be your graph for question number 14.2. So that answers our question 14.2. The same way that we've done 2 is how you do number 3. So please try to pause the video and attempt and see if you're going to get graphs that make sense or that are correct. You can always verify by sending your answer on WhatsApp so that I just cross-check. Then look at number 15. 15, these are radical functions. So radical functions are simply functions that are always found in a square root. Yeah, so how we are going to do 1 is how you do 2, is how you do number 5, I mean, just that there's a negative here. Then how you do number 3 is how we do the rest of the questions 3, 4, and also 6. So I'll try the first one. I'll show you the first one. So this is under radical functions. So radical functions, question 15. The first one, we're saying f of x is equal to, this is x plus 1 in a square root. So here we know the domain of radical functions is that 1 plus x should always be greater than or equal to 0, meaning x should be greater than or equal to negative 1. This is the domain, right? This is the domain, we know this. And also we can just write this type of thing here, so we can solve this. So meaning we are starting at negative 1, then we are going like this. The graph will simply look like that. It will just go straight like that. Let me just try this one more time. This will go like that, passing at 1, because if you do the square root of, when x is 0, do the square root to give you 1. So this is the graph starting at negative 1. That's what you have. So hope this is okay. So the same applies to the second one. When they say x minus, this is f of x is equal to x minus 1, meaning here it's x minus 1 is greater than or equal to 0. So x is greater than 1, meaning we're standing on 1 and then going like this. That's what you have. The domain is all numbers greater than 1. So meaning from here going this side. And you notice that this makes sense because when x is 0, you cannot touch the y-axis, because if you try to put a 0 there to get the y-axis, I mean the y-intercept, to give you this, it does not exist because this is not solvable, right? It is it's a complex number, but on the real number line it has no matching thing that we can plug in. So this is just going to be your second one, 15.2. Then look at number 15, number 3. So 15.3, we already did this guy here. It's the first one, we did it. It's supposed to be located on -1. It goes like that, right? Then there's a +1 outside. So this is already on 1. So if there's a +1, it simply means we move the graph one step up. So this is just going to be, so let me just go back to the original graph. So this has to move up by 1 step. So if it moves up by 1 step, meaning it will camper 1, that's why it's going to start from, and this part here will camper 2. So meaning it's just going to be like this. It's right here in the air, starting from 1, going like that. Then we can erase this other guy. So this is the sketch of 1 plus the square root of x plus 1. It has a vertical shift. That's what we call a vertical shift. It simply goes up a bit. Yeah, so apart from this, it's the same thing even here. This is y minus this. This is the same as that. Then we have a negative that simply goes like that. That's negative that. This is root x. Then we move this thing up by 1 step. So it's simply going to come here on 1 and go like that. Yeah, so this is basically what you get. Yeah, so there's a separate video where you can watch how to do these transformations under radical functions. So this is technically how you're going to do it. If there's a negative, it simply means your graph moves down by those number of steps. So like here, there's a -3. So if we solve what's inside here, 2x minus 3 is equal to what? 0. So meaning x is equal to 3/2. So that's a domain. X is greater than or equal to 3/2. So we're just saying 3/2 is 1.5, right? 1.5 here. We're going like this. That's the sketch. Then we're moving this thing down by 3 steps. So now it's just going to be, if you move it down by 3 steps, -3 plus, there is a 3, is it a 2x minus 3? 2x minus 3. So this is going to be 2x minus 3 greater than or equal to 0. 2x is greater than or equal to 3. So x is greater than or equal to 3/2. So now we're just having this initially supposed to be like this here at 3/2, but then we're moving it down on the negative, so it moves down by 3 steps, meaning it will move like this, crossing the x-axis at, when you put a 0 there, at what? At -3 plus this. This is the answer that is supposed to be there. Yeah, so this has to be really down. So this is what, let me say this just passes like this, because it does not touch the x-axis, because if it was, is it? Oh yeah, it's going to. Yes, it does. Because meaning y is 0, so it does. We need to find that. We equate the whole thing to 0. This is going to be, we do this if it's a y-intercept. So here now we're looking for the x-intercept, right? Meaning this is 0. This is actually solvable like this. We take the 3 this side, and that's 2x minus 3. We square both sides. That's a 9 is equal to 2x minus 3. 9 goes this side. 10, 11, 12 is equal to 2x divided by 2. So this is actually a 6. Yeah, so this is your graph. Yeah, so these are radical functions. Yeah, so you can only get better at this via practice. So hope this is okay. We're just doing modifications. You can check through for the video where we just did these under functions. We looked at this and how to sketch them. Then number 16, they're saying h is defined to be, this is the function h. They're saying sketch the graph of h. So just introduce this. This is the same as 2, 3, x minus 2, 3. This is what you have. I'll put this back inside, then plus a 7. Then this is simply going to be, when you solve this, you are simply going to get x is equal to 1. That's what you get, meaning your graph turns at 1. So 1 is there, so our graph simply looks like this. That's what you have. And when you put 0 where there's x, your answer here will be 2/3. That's what you get. So let me show you a normal standard way of solving this, exam standard. So question 16, you are given h of x to be 2/3 x minus 1, then plus a 7. This is 2/3 x minus 2/3, then plus a 7. Then when you solve this part, we're just saying when you let y be equal to 2/3 x minus 2/3, when you equate this to 0, when x is equal to 0, we can make a table for it if you so wish. X and y, take this. When x is equal to 0, we get a negative 2/3. When y is equal to 0, we get a 1. So technically, this is supposed to be positive because it was in a modulus, but then because I have omitted the modulus expressions, no wonder it's coming out to be negative. So there's 0, negative 2/3, and there's 1, 0. There should be a line that looks like this. Now this line will reflect this part which is down because modulus makes everything positive. That's how it came to be a v that looks like this. Yeah, so it's supposed to look like this initially. Yeah, so that we can remove this other part. Let me just remove this box here. Yeah, so initially this is what we are supposed to have. Let me put it in blue. So our graph should be like this. This is the graph of 2/3 x minus 1. That's a graph here, passing at 2/3. But then we have to move this thing 7 steps up. So we have to add a 7 to this. So we're going to have it here. Yeah, so let me just show you how we are going to get this. So if this is our y-axis, we're just saying it has to start at 7. So let's say 7 is here. It has to start here and also move like this. So 7 plus this, because we're already 2/3 steps up. So 7 plus 2/3, that's a 3. That's a 21 plus 2. That's going to be a 23/3. So this is basically the final answer is this guy here in black. That's what you get. So that answers the question here to say sketch the graph. So we've answered that. When they say the domain is all real numbers. The domain is all real numbers. Then the range is all numbers greater than. The range is y should be greater than or equal to the 23/3 because it just starts from the range starts from 7. I mean 7 going up. Sorry. Yeah. So the range should be above 7. That's what you're having. This guy here is the range above 7. That's what we have. Then they're saying give reasons why h of x does not exist. Why doesn't this guy have an inverse? So the main reason is because it's not a 1-to-1. It's not a 1-to-1. What I mean by that is if you put any number here, let's say the same 23/3, notice it has 2 answers, right? That's the only logical reason why this thing is not a 1-to. I mean, it does not have an inverse. Anything that is not 1-to-1 cannot have an inverse. Yeah, that's the same reason why quadratics also don't have an inverse unless if they are restricted. So that answers here. The answer is that it's not 1-to-1. That's the solution there. That's the reason why there's no inverse. Then now number 4, they are telling us to solve the equation where h of x is equal to 6. So 2/3, then x minus 1 plus 7 is equal to what? 6. We can take the 7 on the other side. This is going to be -1. Then we can multiply, or we can divide by 2/3 this side and 2/3 this side. It will simply give us x minus 1 to give us -1 divided by 2/3. That's the same as 3/2 with a negative. Then we can square both sides. When you square this side, it's going to be x minus 1 squared. This side will be 9/4. This is going to be x squared minus 2x plus 1 is 9/4. We can multiply by 4 throughout. So this becomes 4x squared minus 8x plus 4 is equal to 9. This is just going to be a negative 5 is equal to that. Then the product here is negative 20, and the sum here is negative 8. What factors can we use? So we have 4x squared minus 10x then plus 2x. We use 2 and negative 10. So this is going to be 2x, then you have 2x minus 5 plus 1, then you have 2x minus 5 is equal to 0. So 2x plus 1 and also 2x minus 5 is equal to that. So x is equal to negative half and x is equal to 5 over 2, which is 2.5. So these here are simply going to be the answers to the equation where h of x is equal to a 6. Yeah, so that answers your number 16. Then number 17. So 17, we're simply saying the function s and t are defined as follows. We have s of t. S of t is given to be negative 10 minus x. Then they're saying t of x is also given to be that, where b is a constant. They want us to equate this where they have s and t. When we equate them, s of x and t of x, when they're equated, the expression they give us only has exactly one root, meaning the discriminant is what? Is equal to 0. Remember, under the discriminant, when something has one root, they're saying find the value of b. So this is what we're going to get. So we're going to have, this is question number 17. We have s of x. So s of x is equal to negative 10 minus x. Then we're having t of x, which is equal to 2 modulus of x plus b minus 8. So here we equate them. So we're just going to say 2x plus b minus 8 is the same as negative 10 minus x. I take the 8 this side. This is just going to give me negative 2 minus x. Then from here I can square both sides. When I do that, this will be 4x squared plus 2bx then plus b squared. Then this here will be 4. And this is going to be 4x then plus x squared. Then here I can just say we have 4x squared plus 8bx then plus 4b squared. Then I'm having 4 plus 4x then plus x squared. Here we can just get a 3x squared then plus 8bx minus 4x then plus 4b squared minus 4 is equal to 0. According to this, we're saying the discriminant, since this thing has one root, meaning b is 8b minus 4 squared minus 4a, and my c is 4b squared minus that, this should be equal to 0. Your a is this. Your a is the coefficient of x squared. Please don't get this twisted. Don't confuse what we're doing here. Your b is the coefficient of x, which is 8b minus 4. That's what you've put here. Then your c is this whole thing there. So now we're solving this quadratic down here. This will be 64. We just simplify it. This is going to be a 64 b squared. This is going to be 4 times 8. This is going to be a 32 by 2. That's going to be a negative 64 plus a 16. This is a 12 by 4. This will be a 48 b squared, and this will be positive. We're saying we have 12 by 4. That's also 48 is equal to 0. So here we can have 64 minus 48. So we have 64 minus 48. That's a 16. So 16b squared. And we are having negative 64b. Then this is plus 64. This is equal to 0. This is just b squared minus 64 divided by 16. That's a 4. This is a 4b. And this is just a 1. is equal to 0. Oh, this is a 4, I mean. Then from here, we can just say b minus 2 squared minus 4, then plus 4 is equal to 0. When you complete the square, meaning b minus 2 squared is equal to 0. So b is equal to 2. So the value of b should be 2 for s of x to be the same as s of t. That's what you have here on number 17. Hope that's okay. Then number 18, they're saying solve the following equations. This is what you have. So here, or the first one here, the first a, this should have been a, this should have been b. So on 18a, you are seeing that there's a modulus and a number. So the way we do this, everything is the same. We're going to solve them in a similar way. So number 18a, we're simply going to be squaring both sides. So on number 18a, I'm going to do the first one and also the second one. Yeah, that will answer everything else. So question 18a, this is 3x then plus 4 is equal to, this is your 8, so we square both sides, 3x plus 4 square and also 8 squared. This will be a 9x squared plus 24x then plus a 16 is equal to 64. This is 9x squared plus 24x. Then this is going to be minus 48 is equal to that. We can divide this by 3. 3 there is 3x squared. 3 here is simply 3 into this is supposed to be 8x. Then this is going to be 1, that's 16. From here, the product is negative 48. That's what you have. The sum is 8. So the factors will be, so the factors here will just be 12 and 4. Is it? So we're going to have a negative 4. So that we have 3x squared, then minus 4x, then plus 12x, then minus 16 is equal to 0. This will be x, then this will be 3x minus 4. This will be, there's a 4 there, that's going to be 3x minus 4 is equal to 0. So x plus 4 and also 3x minus 4. When you solve this here is supposed to give you x is equal to negative 4 and also x is equal to 4 over 3. So now we have to test the side. You need to be checking for extraneous solutions. So we're just checking. Here, if you put our answers, which are simply negative 4, so we are having the expression, the question was modulus of 3x plus 4 should be equal to 8. So if I put this expression there, that's going to be true. If I put negative 4 there, that's also going to be true. So these are both solutions because modulus makes everything to be what? To be positive. Yeah, so question 1, we've done it. So I'll also do the second one there. We also square both sides. So the second one, that's question number 18. Second one, they are saying modulus of x plus 6 is equal to the modulus of 3x then minus 24. So from here, we're simply going to have, I can just simplify something here for us. I can just bring the 3 outside. This is x minus. That's going to give us 24. That's going to give us 8. I think this is going to be 8. So now here, I just want to square both sides. That's going to be x plus 6 squared. That's 3x minus 8 squared as well. This is going to be x squared plus 12x plus 36 is equal to, that's a 9x squared. That's going to be 16x plus 64. Then this here is going to give us something that will be comfortable with solving. This will be 12x then plus 36 is equal to 9x squared. Then we are having 9 times 16. That's simply a 144. So we're having 144x. Then plus, we're having a 9 multiplying a 64. That's a 576. Then from here, we can take everything here on the other side. That's going to give us 8x squared. That's going to give us minus 36, that will be 540. Then we are going to have a 144 minus plus 12, that's 156. So 156x plus. So if we check, can these all be divided by 8? So we check if we're able to solve this. Can we reduce them? Is it possible? 540 divided by 8. Okay, so they are not all reducible. Just use the Chimabasi equation. This will just be, it's easy to just use this guy. 156 squared minus 4. This guy here. Then we're having 2a. 156 plus or minus. So this will be 156 squared. Because of time, I'm just going to make it fast and use a calculator. So if we use a calculator this side, the square root of our answer, we're getting an 84. When you get done, this is a 610. So from here, we're just saying we have 156 plus 84, then divided by 16. So the first answer is 15 that we're getting, and the next one is 156 minus 84, then divided by 16. That's a 4.5. That's simply 9 over 2. So these are the two answers that you are getting. Then we test. You always have to test to see if the right hand side is going to be equal to the left hand side. That's what they mean by extraneous, because not all solutions are going to work out. So you have to test. If you put a 15 here, 15 plus this, that's a 21. 15 by 3, that's a 45. 45 minus 24. So 45 minus a 24, that's going to give us what, a 21. So 15 works. How about you try 9 over 2, 4.5. You also check if it works. If it doesn't work, meaning that's what we say, it's an extra solution, extraneous. It does not satisfy the equation that you solved, but it is part of the solutions. Yeah, so that's what you have. Then for part B, so what we've done here for the first one and the second one, that's what you do for even the third and the fourth. Yeah, so that's what you have. Then number B, so here I'm going to solve the first one, because how you solve the first one is how you go about solving the second and the third one. Then I also solve the fourth one, this guy here. Then from here I'll solve one of these expressions there. These are very simple. We've done this before. There's a separate video, I think, for this. Yeah, so you can still reach out if you get lost. Yeah, but these are just straightforward. Yeah, so now we are going to solve the first one. The first one is, so let's call it 18b. They're saying we are having the square root, so that's the first one, x plus 6. Then here we're having plus 2x is equal to 9. So you're seeing that there's only one square root. Here we'll take everything else to be on the same side. So everything that doesn't have a square root should be on the other side. This is what you're going to have. Then from here, you square both sides. This will give you x plus 6. This will be 81. Then this is going to be 18. That's negative 36x. Then plus 4x squared. This is going to be 4x squared minus 37x. Then this goes this side. We're having 81 minus a 6. That's a 75. So this gives you that. Then you solve this. So you can just solve this and finish it off. Then check the answers that you're going to get. So I think I should be leaving them halfway for you. The second one is the same thing what we've done. So I said I'm going to do the third one as well, because what we did on the first one is what you do on the second and third. You take the 5, so like here, you take the 5 on the other side, right? Then you square both sides. You take this on the other side, then you square both sides. So how about number 4, when you have 2 square roots? Yeah, so let me do number 4, number V. You have a 2x plus a 3. Then this is minus x minus a 2 is equal to a 2. Here, we just need to have one side with a square root. So we take 1 to the other side. This is going to be 2x plus 3 is equal to 2 plus x minus 2. Here we square this side so that this part cancels. That will be 2x plus 3 is equal to this by itself twice. We're just saying 2 plus root of x minus 2 multiplying itself twice. This is going to be 2x plus 3 is equal to, there is a 4, there's a 2 root x minus 2, there's a plus 2 root x minus 2, then there's a plus x minus 2. This here is simply going to be, if you take the 4 on the other side, that's going to be negative 1. Yeah, so we're just going to get anything that is not under the square root should come on the left hand side. That's going to be negative 4. We've taken this guy and also take the x and also take the negative 2. That's going to be positive 2. This here can add to just give us x minus 2. Then here we're having x. This is negative 1. This is just going to give us a 1 is equal to, there's a 4, then x minus 2. Here now again we square both sides. This will be x squared plus 2x plus 1 is equal to 16, x minus 2. Then from here we can now say this plus 2x plus 1 is equal to 16x then minus 32. This will be x squared. This is minus 14x. This is going to be plus 33 is equal to 0. Again, you solve this guy here. So you solve. Again, you finish it off. That's how you do. We just have to square both sides, so that should help. Yeah, so questions like this, you just sum it up, then cross multiply. Same applies with that. Same applies with this. Though this will turn into a polynomial, so you can check it out. You just sum up this part, then cross multiply. This one here, you break it down. So here we square both sides. Then here you have something that is in a rational form, but there is a modulus, so something that looks like this is equal to 3. You can write this as x plus 1 modulus over x minus 1 modulus like this. Then this changes, it becomes x plus 1 is equal to 3, then x minus 1. Then here you square both sides. Yeah, then you get your outcome. This one here, you multiply everything. So this is root of x, then minus 6 root of x is equal to 1. Multiply throughout by root of x, that's going to be x. Then minus 6, then this is going to be root of x. From here, square both sides. This is going to be x squared minus 12x plus 36. This is equal to x. Then you have x squared minus 13x, then plus 36. Then I'll solve this. Yeah, so you solve this. And then test the answers that you're going to get. So this is basically what you have. You could have just added this. You'd have just said the common thing is root. Then you say this is just going to be x minus that is equal to 1. Then you cross multiply. It will still reach you here. You will still get this. Then here you square. You still arrive here. So however you do it, the outcome still has to be the same. For this case here, you just square both sides as well. Yeah, so that's what you have. And I think we've done something like this. This we've done it already. It's this guy here, right? This is here. Hope that's okay. So that's on number 18. Then on number 19, these are find the values of x that satisfy the following inequalities. These are inequalities. And whenever we're dealing with inequalities, we always focus on the sign that has been given. So if it's a less than, meaning we're looking for a region where the outcome in a table form, if we're testing using a table, has to be negative. Yeah, there's a completely separate video where we just did question number 19, but I'll still do one here or two to just guide you. So like the first one here, it's a quadratic. This is 4x. We can take this on the other side. That's going to be 3x squared minus 4x minus 4 is less than 0. We solve this. So if we were to solve this, we're simply having, this is going to be, the product is simply negative 12. The sum is negative 4. Now we're looking for factors. So what factors can we use that can give us 12? So we can try to use negative 6 and 2. Yeah, is it? So that if we say 3x squared minus 6x then plus 2x minus 4. This will be 3x, then this will be x minus 2. This is going to be 2 and x minus 2. Yeah, so this will be 3x plus 2. And this will be x minus 2 less than 0. Then we test now. So on testing, we just solve these guys that we're from getting. We solve these. This is going to give us x is equal to negative 2 over 3. The other one is x is equal to 2. X is equal to negative 2 over 3. Then the other one is just going to be equal to 2. We test. So by testing, you say this is 3x plus 2. This is x minus 2. These are the factors that we are having. You put in a number less than this, let's say negative 10. You put negative 10 there, this will be negative, this will be negative. You put a number here, let's say 0. This will be positive, this will be negative. A number here, let's say 3. That's positive, that's positive. The outcome here will be positive, here to be negative, here to be positive. They want where this expression is less than, right? Where it's less than. So they want this region. So it's just negative 2 over 3 to 2. They said strictly less than. So it will just be open, these ends, they are open. So that's what you do on the first one. That's how you even handle the third one. It's a quadratic as well. When you take the 120 to the left, yeah, then how we do the rest is just by taking the left everything here. So like this guy here, or even this guy here, this is 2x minus 1, x plus 2 greater than or equal to 1. You take the 1 this side. This is going to be 2x minus 1, x plus 2 minus 1 is greater than or equal to 0. This will just be 2x minus 1, then minus x minus 2. This is x plus 2 greater than or equal to 0. This now will change to be x minus 3. Then you have x plus 2 greater than or equal to 0. Then you solve each one of them. Then you simply make up a testing table. Because we're looking for the solution set. These are inequalities, so there's no exact value. So you have, there's a negative 2 as one of the answers. When you solve the down part, then there's a 3 on top. If you try to check, let's say negative 3, there will be negative 3 will be negative. So the result here is positive. You put a 0, it's going to be negative and positive. So this is going to be negative. You put a 5, that's going to be positive, that's going to be positive. So when they say greater than, we mean these ones here, right? Greater than or equal, so even the boundaries are included. It will be negative infinity up to negative 2, closed union, from 3 to positive infinity. That's basically what you have. Yeah, so if you do have any challenges on this, please check through the video. You can let me know if you need access to links for those that are registered. Yeah, because some videos are private, so please feel free to let me know when you have queries, and you can just send your rough work so that it's easier for me to actually respond and guide you to see where you're going wrong. Yeah, so you can send your full attempts to my WhatsApp number. Thank you so much for watching and until this end.